Hello, everyone, and welcome to today's web seminar, Practical Applications of AI and Machine Learning for Smarter Test Automation, sponsored by Parasoft. Thanks for joining us today. Before I hand it over to our speakers, let me explain this console. The three panels on your screen can all be moved around and resized. You should also see a widget toolbar at the bottom of your console. By clicking that Handouts widget in the middle, the one that looks like a piece of paper, you can download a PDF of the speaker's slides and some other resources from Parasoft. If you have any technical issues or questions, please type them in the questions and answers panel to the left. There will be a Q&A session at the end, so feel free to ask questions throughout the presentation. This event is being recorded and will be made available to watch on demand later. We'll send you an email when the recording is ready so you can watch it. And with that, I'd like to hand it over to our first speaker, Mark Lambert.
Thank you very much, Beth, and welcome to today's webinar. Today we're going to talk about practical applications of AI and machine learning for smarter test automation. Now, I do apologize for the delay in starting today's webinar. We have run into some technical issues. Hopefully, we don't run into any more today, but we'll see how we go. Well, my name is Mark Lambert. I'm the Vice President of Products at Parasoft. We specialize in software test automation, everything from when the developer writes the first line of code all the way through to functional test automation, through unit testing, as well as deep analytics across the way. Now, we're going to profile a few of our technologies today, but what I'm very, very happy to say is I'm actually in the room with Diego from Forrester right now. And what I would like to do is I would like to invite Diego to introduce himself.
Thank you, Mark. And it's actually interesting and a pleasure to be here in the same room doing this webinar with you. And so I'm Diego Lojudice, and I'm Vice President, Principal Analyst from Forrester Research, which is a company that does, of course, research, as the word says, in the industry from a technology perspective, vendors and GSIs and what end users are doing with technologies and advisory in that space. My role is to cover. I cover testing. I cover application development and testing. And so today I'm going to share with you some of the recent research that I'm doing. This is ongoing, so it's interesting. You're the first to hear and see some of the stuff that. Of the findings, and be happy to answer questions after. But anyway, let's kick it off in the interest of time. So, well, before we get into the cool stuff of AI, let's just a quick peek on where are we with testing today. So this is from the biannual survey that I ran in Forrester on Agile, and with Agile teams, basically, asking them, those that are doing Agile, what type of barriers they're having in adopting Agile and DevOps. And as you can see, testing is, of course, part of the challenges, and it's usually in the form of skills issues, lack of skills, in testing itself, in automating testing, especially in some of the new practices that Agile testing and DevOps require, and as well as automation. Here it mentioned tools, but it's not just the tools that they lack or they don't have in their infrastructure. Organizations don't have it. It's also about the practices and how to use them. So this is another data point that comes from, I recently did a wave on omni-channel functional test automation with the top leading companies that have products in this space, and they all offered, 3 of their best customers in the wave. So we surveyed about 45 end user companies, Fortune 1000, Fortune 2000 companies. And you can see that the response in that process, it's kind of a bit all over the place, right? The good thing is, I mean, there are, of course, some of the end users that are using those tools claim a high percentage of automation, right? Above 81% is quite high, but it's kind of dispersed around all over the map, even below 10%, which is kind of a bit depressing if you think that these are of the some of the leading tools that are in the clients of the tools of some of those leading tools in the market. But Some other data around automation also shows that it's still low, right? The same agile research that I was mentioning a minute ago shows that those agile teams, the automation, generally speaking about automation, it averages between 30 and 50%. And the World Quality Report that Capgemini does every year shows below 20% for all, between 18 and 20%. The point is, we still are struggling in automating testing more. And if you think about automation being something hard, then you probably will get even more depressed when you look at how hard it is in testing and automating in a continuous delivery and at scale. You can see that in a continuous delivery organization setup, testing is happening at various steps of the process. It shifts early on. It starts really early in the process, and it continues even when stuff is in production. At least that's what some of the high performance leading organizations do. So anyway, automation is a challenge. And the other interesting data point of where we are is, how do we serve, and which personas are we serving in an organization from a testing perspective? Well, you can see that again in going back to the data that comes from those 45 technology leaders of end user companies that are working with the most advanced automation tools out on the market, functional test automation tools on the market. You can see that they're doing a pretty good job, or they're a pretty good job for the technical tester, the guy that kind of is in the middle between being a business tester or having no knowledge about technicalities and what the in-depth technical details of what testing requires, and the developers, which are instead the guys that like testing, using basically not leaving their IDE and coding, scripting, automation, and doing unit testing. And the technical testers are well served. The developers are also kind of happy, well served from within this sample. It's the business testers where we are still lacking and dragging. And I would say, the question is, right, we just, we kind of said and shared that automation is a problem. Skills are a problem. The personas that we probably need to address in an organization, we're not really serving all of them. And so the question is, can AI actually do something to help? Is there any application of AI that can help improve the way we test? So first of all, just a quick overview here. These are the technologies that are in the AI ecosystem that come with AI. Things like you might have all heard, I'm sure, machine learning and deep learning, especially, which is like the latest, hottest trend in AI. There are technologies around reasoning and language processing, which is natural language generation, text understanding, it's voice transcriptions. There's various subcomponents of technologies, and video and image and video image processing as well. And you can see that those red arrows show how in the new wave of AI, deep learning is kind of trying to improve all of those areas and getting them better. And so, but I guess that's the technology landscape. But the question is, what does AI mean, or what is AI? Just to give a definition, this is a definition that Minsky and McCarthy, two of the early fathers of AI, describe artificial intelligence as a task that performed by a program or a machine, that if a human carried out the same activity, we would say that the human had to apply intelligence to accomplish the task. Now, the way I see, modernizing that definition is really systems programmed to learn. I think that's the big difference between the first, version of AI and the latest AI wave that we're having, which is we're not programming the systems with particular techniques. We're really with particular techniques to reason. We're programming systems that can learn in an autonomous way, and that's what deep learning is really doing. Okay. So that quickly said is, what can AI do for humans, and especially what can it do for testers, I guess? Well, there's two main things I would like to focus on, and that I think AI does. On one side, it augments individuals. People talk about intelligence augmentation, right? Can I use AI to make better decisions faster? Can I use AI to make better decisions based on data, on the structured and unstructured data, on what I know from the context that I'm in, to do a better job and make better decisions? And on the other hand, can AI actually help us automate more? I mean, we already do automation in testing, and there's already technologies out there. But can we do automation? Can we do more? Can we improve automation with AI? So we want to focus on augmentation and automation. And the question is, especially from an augmentation perspective, can we augment testers, right? And all of the personas in testing. So can we, for example, augment developers to do a better job in their unit testing? Can we help them half the time that it takes for them to write their code, so that something else takes care of the unit test generation, for example? Can we augment the technical testers, which are with insights, so that, for example, they can prioritize better what to focus on testing, or to manage risk in the process of testing? Can they not just think about automation, but smarter automation, perhaps, and optimize how much and what we automate? And third, is, can we also augment business testers? Well, they're kind of been a bit left. As you can see, the tools today are still struggling to address business testers. It's like, if you get at that high level of abstraction, you can't really automate much. Can AI, help fill that gap up, where now you are increasing the abstraction, the intelligence of a tool, so that even a business tester can start doing some level of automation, some type of testing that he's doing today in an automated fashion? So last year I launched this research. And basically, I reached out to the gurus in testing in the market. That is, gurus from vendors, companies, people like Mark, that's here, GSIs, and other, other interesting folks that are deep into both, in the testing world, and ask them, were they planning, or do they understand, what can be and how can AI be used and leveraged in the software development lifecycle in general? The questions were across the software development lifecycle. And you can see that from the data, really, the testing came back as being the hottest area, the area where there were more use cases, potential use cases that we could use AI for. I would say today, if I ran this questionnaire again, I did this in 2016, I'm sure that the release step would also be hot red, and I would still consider the early requirement step and the IDE environment an area where, yes, some AI can be applied, but I think medium interest is still right, and it's you could look at this as a maturity, perhaps. But when you look at the data, right, we do this developer survey, and we reach out to over 3,228 developers worldwide, and I asked them a seeded question on, are you using, which of the following statements reflect your development team's approach? Are you using AI, in other words, and machine learning in software testing at all? And you can see that the respondents, there's 27% said, no, we don't use any. 26 we plan, but there's a whopping 37% that claim they are using testing. And I think that, that is a little bit, too positive compared to what the reality is. So I went a little bit deeper and digged into the data and found out that actually things change from region to region. On one side, we know when we do these large surveys that Asia Pac and China, we get more positive results compared to the US and Europe. Europe is somewhere below that 29%. As you can see, in fact, that 37% of we use AI machine learning to test better goes to 29% for the US, but it goes really high for China and India. So that's why I think we have a high number. That said, we do know also, and everybody I think knows that, is that in China there is a lot of AI going on, and so people are using AI with testing or testing, for testing solutions. But I would say let's just look at this as a trend and as an intent. People are aware of the fact AI is maturing. Testing is an area where AI can be applied. But then I asked, what is it that you're using it for? And really, there's two broad categories, right? We don't need to go through the details of this slide, but there's two broad categories. And the biggest one, 61%, is in the defects, bugs area, right? Can we help like doing things like reducing mean time to repair? Can we do predictive maintenance, basically, which is what in other industries people have been doing for years with predictive analytics, which is kind of considered a subcategory of AI machine learning. So that's one of the biggest. So one is managing bugs in a much better way, and we will see some more use cases as we go forward. The other areas all belong to, can I help the tester improve the way he works, the prioritization he makes in his process? Can he optimize the testing process, the management of testing itself? Can I get lots of insights that will help me focus on the right areas for testing, on what I can automate, where I would get more money for the work that I'm doing in automating, and where to focus that automation, and so forth. There are some, however, that also claim they're using some of AI also to increase the level of automation. So that's the data, that's the market. And so now I'm gonna quickly go through some use cases, because I've been reaching out, as I said, I'm doing this research and reaching out to GSIs, vendors, that starting from that angle, because it doesn't look like clients want to disclose too much the experimentation that they're doing in this space. But what are the use cases? And I'm trying to distinguish what are the myths, or mostly myths, from realities, or mostly reality in being something that you can use right away and is solid. Well, nothing is really solid and right away, because these are all new solutions eventually that are coming to market. So one of the areas, first area, is visual testing. And as I mentioned at the beginning, deep neural networks are used for, are reaching a very high level of precision in image recognition and in video and image and video recognition. And so, that is definitely an area where testing needs some help, right? Basically, now you can have a system do what a human could do visually when he's testing and looking at something. You can get data from that. You can support humans in doing a better job in being really precise on what might be right and what might be really wrong, when it's hard to kind of identify in the image on what they're seeing, the difference. But it's also, in a more simplistic way, this, but what you want to do is you want to have an intelligent recognition of displays and what's displayed, that is showing in the right way when you're looking at it on a big screen versus when you're looking at it on a small screen, where the layout might be completely different but right. Well, if you do image recognition, as soon as something is different, even a small pixel, different color, the test is going to fail. Of course, object recognition also kind of works around, has some workarounds around that. But what AI can do is actually a complete different layout that fits nicely on the mobile phone, can be completely different from what I see on the large screen. But that, that testing should not fail because it's right. This is mostly a reality, right? I would position this in the bucket of the most, close to reality type of technology that is out there today. The second use case is shorten mean time to repair with intelligent defect management. So this is the defect space, right? It's that area that got that high 61%. But really, it's for the use case number one. So basically, can we cluster defects in categories, making sure that we know which categories need to be dealt with in what way, so that we can quickly find the issue. There are technologies out there that allow you to kind of quickly find the area of the code that might be resolving that defect found into production. More sophisticated is defects assignment. Who can fix the issue? So, defect number one is a tool technology capability that small startups and testing companies are implementing. But number two is more something that I've noticed that I've found out through GSIs, global system integrators, testing service companies are doing, because now you can also, having data around the profiles of the developers, having data around the teams that and the tools that generate lots of data during the software development lifecycle, you can actually start identifying which team and even who the developer might be the right developer with the right skills to fix a bug. So that reduces mean time to repair. Again, this is, especially number one, is mostly a reality. And number two, there are projects out there that system integrators are doing with large end user customers to address the issue. Test lifecycle optimization. And so this is really I think one of the key augmentation areas for testing. And there's a number of things that can be done. A couple of the use cases that I've bumped into is, one is, well, you can use a lot of data in production to find out what are the features of an application that customers are using. And based on that, you can intersect it with your test cases, regression test cases, for example, to find out maybe and optimize and retire test cases that are not, test cases that are testing functionality that is not used into production, and just retire that. Or find out that there are areas of your application that are highly used, but testing is kind of weak or low. And that's kind of identifying also higher business risk areas, right? The other question is, can I use the data during the software development lifecycle, data coming, from log files, from the testing tools, from Jira, the bug tracking tools? Can I identify areas that are of a higher risk? Can I identify, crunching all that data, what I should test next? Well, those are the cases that this use case would look at. And I would also classify this as mostly as a reality, right? So this is something that some organizations are doing, and they're getting some results, and of course, improvement again in all of these areas we're going to see going forward, but it's mostly a reality. Let the bot do the hard stuff behind the scenes. So Mark is going to talk, a lot around this specific use case, and Mark, I think you'll be happy to see that I am classifying this as mostly a reality, but then it's your job to prove that I'm right.
And I will take that challenge. Yes.
So anyway, what are we doing here? Well, basically, we are actually, API testing is hard for developers, even for developers. Can we, first of all, make it easier for developers themselves, but also can we maybe make it easier for others to use? And these are can the tool hide the complexity so that a technical tester and even a business tester one day could exercise better testing, doing API testing without necessarily having a detailed technical background? And this is all about creating and generating positive and negative test cases. So this is mostly a reality. Automated customer experience. So now we're getting into the area of what I call myths, or mostly myths. These are real cases though, right? They are myths, but they're real cases. There are, the question is, can I test customer experience, meaning things like ease of use? Today, ease of use, only a person that sits in front of a computer, I can have him test and ask him, what did you like, what you didn't like? But can I test that in an automated way? Can I test emotions? Can I test that someone is happy when they're behind the screen doing what they're doing? Can I test the efficiency of the application in that the customer was able to take all the value that they were really aiming at, by working with that app, and was it making them happy? Now today, I would say that today I will, today this is mostly a myth, but there are some, LTI, which is a system integrator, and other system integrators also doing some work in this space, using, for example, brainwave tools, hardware that you can buy at the supermarket for $100 in the United States, or in Target or some other retail, and use that brainwave technology that generates data exactly around the fact that you are getting frustrated, you are being happy, you are being efficient in using an application. If you couple that now with using visual emotion and using deep learning, that actually does recognize, how your face, how your expression in the face is changing based on how you're using the application, you can actually get a good idea of what's the customer experience, the user experience that customers are going through in using that application. Now, this is mostly a myth. If you want to completely automate this, crowdsourced testing companies, testing service companies also are using some of this technology to kind of give the crowd some automation in the user testing that they're doing, because crowdsourced testing does focus a lot on user testing. So this is another interesting use case which I found companies working at, and when I mean companies, both vendor side and end user side, and rating 100% unit test. The equation here, halving 100%, means that today we know that when you build software code, if you do unit testing, it's going to double the time it takes for you to build that code. And so sometimes developers skip it. Companies are not happy, developers taking too much time. But actually that's a mistake, because unit testing is really important to really provide the right level of quality and technical testing before even doing other types of testing, like functional testing, which are more matching and making sure that the business requirements are met. And here again, I know that, Mark, this is another use case that you're going to be talking about, but if you consider the 100% code unit test generation from code, that is a myth. It's a myth where some companies are getting closer to, but it's mostly a reality probably to get somewhere around. Do you think that 50% is?
Yeah, I actually think you're greater than 50%, but less than 100. That's the reality, and it's, as you were talking about before, it's really the best use case is an augmentative workflow rather than an autonomous workflow,
right,
especially when it comes to unit testing.
Well, unfortunately, we're far from autonomous testing at this point, but we'll comment a few things about that in a minute. And so this is this other use case, which is again another myth, but this is about really automating and optimizing, going beyond just the automation of execution of test cases. It's automating also the design of test cases, or it's automating the design from natural language driven requirements, for example, because natural language processing is one of the promising technologies that we're all leveraging. Although it's promising, it's not yet fully usable in a general purpose case. These use cases become more real, and this is really a myth, but it becomes more real if you constrain the domain and you define the terminology for the domain and you define specific words, which leads us into the next use case, which is the same type of use case, but now we're working on models, we're working on the language. And here again, you can apply some optimization. Now, you might, some of you might be using technology that is out there, which is kind of not really AI or some of the recent deep learning, but there are algorithms leveraging analytics and some other statistical Bayesian technology to really do the same thing. So while the previous use case is mostly a myth, this is mostly a reality. But the difference is, remember, the other one is focusing on natural language. It's focusing on requirements at the natural language level. All right, so this is my last use cases, and I challenge you all to remember which icon means what. But really, quickly, let me go through this, trying to just show where we are overall from with these use cases. And these are not all of them, by the way. But as you can see, these are all going from augmentation to automation. The ambition is to have more and more automation with them, of course. But from customer experience, that is all the way to the left, being more of a myth, to automated test case design generation from language generation, again a myth, and automated unit test generation, all full 100%. When it's all full 100%, it's again mostly a myth as well, and highly automated. It can be highly automation driven, I guess, in the future, but also augmentative for testers. And then you've got the other use cases, the testing lifecycle optimization, the identification, the bug, all the work we can do around issues and issue management and clustering, to the automated test, the API testing generation, to the visual testing, and to the automated test case generation on more standard models. And so anyway, this is, again, as I said, research ongoing. Happy to get questions and get feedback on this, and we will refine this. And I will be refining this as we move forward. And with that, I thank you all for your attention. And Mark, hand it over to you.
Thank you, Diego. So actually, we'll go ahead and we're going to skip through our poll, because I think with our technical difficulties at the beginning, we're running out of time. So let's just kind of talk about. So what Diego presented us so far today is his ongoing research as to where AI falls into assisting with the software development process, and obviously with a focus on testing and how we can make testing smarter. As I said at the beginning, what we do at Parasoft is we focus on test automation, and we focus on how we can help an organization create a streamlined testing process. And what we do is we look at how we can introduce technologies and advanced analytics and artificial intelligence to streamline that process. All of the test automation strategy that we focus around at Parasoft is taking into account what a lot of people on the call today are probably familiar with, the test automation pyramid. Focusing on a foundation of unit tests and service level or API level tests to complete out as much business logic, business validation as possible, and then minimizing the reliance on end-to-end UI level testing, which is harder to automate, and obviously it has to have the entire application up and running before you're ready to go. However, while we know that this is fundamentally easier to scale and easier to automate, so we can more tightly integrate this into our CI/CD pipeline, we know that organizations are struggling. So when we talk to organizations, we typically find that they're still heavily leveraging manual testing. Some of the research around developer surveys shows 40 to 50% testing is still done in a manual effort. Then with reduced levels of automation as you go down the testing pyramid. And when we actually dig into that data a little further with our clients, we identify that really there are some fundamental problems at some of the hidden layers of the testing pyramid, such as API testing. So at Parasoft, what we've done is we've introduced technologies that can help with those two lower levels of the pyramid. Our Parasoft SOA test technology for helping with API tests, as well as our Parasoft JTest technology for helping with JUnit test cases at the lower levels of the pyramid. So let's just talk about the API testing for a second. API testing is recognized as being a very powerful technique when it comes to a test automation strategy. It can reduce the time it takes to diagnose and identify the root causes of problems in your code base. And it's also a great communication channel between the development and the testing organizations. However, we do see a number of cons associated with it and a number of limitations. And one of those biggest limitations is the lack of knowledge between how the APIs were designed and how the APIs were used. In essence, often development teams will implement an API, publish a Swagger document or an Open API document and say, here's my contract, here's how it should be
how it should be used. And then the test team go, okay, great, but I don't know how it is actually used. So you end up waiting until you got UI available and you test through the UI. And this is actually one of the challenges that we took on at Parasoft by taking our SOA test product and injecting artificial intelligence and machine learning into that technology. SOA test is designed so that I can help a tester create a test by design by consuming those contracts. It's a highly UI-driven infrastructure, so targeting at those technical testers so that you can create very feature-rich test scenarios at the API level. And then we added, at the beginning part of the summer, May 1st, we added the first version of our Smart API Test Generator, injecting AI into the process so we can understand how your application is used and then create tests based upon that application use. So how does that work? Well, the Smart Test Generator is a plugin to your Chrome browser. That Chrome browser plugin actually captures the interactions that your web UI is making with the backend API. In essence, pulling out the under the hood wiring, and it then passes that onto the SOA test engine. That SOA test engine is either running on the developer or tester's desktop, or it's running as part of your infrastructure. That traffic is sent to the AI engine, where it analyzes the data, identifies patterns and relationships, and then generates me a test case that I can then reuse continuously, plugging into my CI/CD pipeline without the need for the UI. So this is the first flow. This is the leveraging AI to actually build in the patterns and relationships into the tests. Earlier this month, we actually introduced the next generation of Smart API Test Generator, and this is where we started to use machine learning. We looked at this and said, okay, how can we augment what the developer is doing today and make the engine smarter? So those test cases obviously are going to fall into some kind of test repository. So what I do is I record my interactions, the AI builds the relationships. I would then maybe look at that test and add some knowledge to that test, or maybe I've got some tests that are built by design, and I have this large repository of information, which is really, really powerful. So what we said to ourselves is, okay, we've got all of this data in this test repository. How can we extract out that data and use it? So what we did is we introduced the ability to be able to train the brain. So here what we can do is by taking your existing test repository, whether or not your SOA test tests were created using Smart or they were created by design, and taking those and analyzing them, extracting out, in essence, rules that I can then use to feed the brain and make the tests more valuable, injecting a learning process into the loop so that I can constantly improve the analytics and how we can make that more powerful. Now, unfortunately, my animations didn't work quite right on this slide. But why do I need AI? What is the problem that I'm trying to solve here? There is a gap between how an API was designed to be used and how the UI is actually using it. And often that exposes very specific business logic challenges. What Smart does is it not only takes a series of steps, but chains them together to assemble a jigsaw puzzle, identifying what the business case and the functional scenario is that you're trying to validate, and automating that at the API level where it's more stable, resilient to change. It's easier to automate because of the less requirement on the overall testing infrastructure. Now, this actual workflow has helped one of our clients in the medical industry, in the healthcare industry. And I'm just going to see if this slide will move forward. So what we have here is we've got an example of one of our healthcare clients. So our healthcare client was growing through acquisition. Numerous teams or numerous healthcare providers coming under an umbrella organization. The development team were bringing together all of the APIs that were driving those different organizations and bringing them together into a centralized UI. But the challenge was that UI was constantly changing. So what the development team were tasked with was try and create me tests at the API level. The challenge is that when I go down that path, those APIs are not used in a single way. They're actually used in different ways depending on the API, depending on what that team is doing, and the UI provides the context. If I don't have the UI, then what happens is I'm stuck with a bunch of jigsaw puzzle pieces that have no faces. When I have that, I don't know how to plug them together. I don't know how to test them. So what we did was by injecting the Smart API test generator into the process, we're able to observe the interactions that are going on with the application. And those interactions are then captured into tests so that I can build tests that are directly going against the API independently of the UI. Ultimately giving me the ability to take those tests and shift them left, enabling them part of the CI process so that they can be executed continuously. This workflow actually saved this organization 50% in test creation time. They weren't having to figure out all of the business logic. They were able to capture the business logic with the UI in its current state. We're able to build the test automation around that business logic, and then they were able to automate that continuously as part of their CI/CD process. Now, one of the beautiful things about these tests is not only are you testing the API, but you can take those same tests and reuse them for early stage performance testing, enabling shift left of performance and validation of non-functional business requirements. Those same tests that we created by monitoring the UI, we can take and execute under load so that we can identify potential problems in my application before I get to my later integration testing stages. So this is how we can help API testing. We did talk about, or Diego also talked about unit testing though. So let's look at unit testing, and Parasoft has got a long history with supporting unit testing developers, especially within the Java community. So we know that unit tests are very powerful. There's a lot of advantages to building a solid foundation. They're highly automatable. You can really integrate them very seamlessly into your CI/CD process, but they are actually rather costly. As Diego was saying, you know, the cost of unit testing, typically most organizations would recognize that a day of development cost should have a day of unit testing cost. However, many organizations are unwilling to spend that time on that practice. And also, there's another fundamental problem, is that most developers don't like doing it. Now, developers want to release quality code into the market, but what they're really not trying to do is they want to spend time developing code. Certainly, I know that when I was a developer, that was the thing that gave me joy, was developing something so I could actually see my application work. It wasn't in the testing piece. So what we do at Parasoft is we have Parasoft JTest. Parasoft JTest is a comprehensive software quality tool for Java developers. It actually has a very deep code analysis engine embedded within it that is designed to uncover reliability and security issues within the application, going beyond what I would get normally with open source. But then it also has key capabilities around unit testing, helping the developer augment their process so that you can create meaningful unit tests and do it in half the time that you would cost you previously. So how do we do that? What Parasoft JTest does is we kind of break this down into four pieces. The first piece is that Parasoft JTest will help you create tests for your existing code base by analyzing the code, understanding relationships between the code, implementing mocking for you so you don't have to do the complexity of mocking, guide you down the path of how to create good tests. It'll guide you to say, okay, how do I create assertions? How may you want to do more advanced mocking potentially? How can you identify instabilities in the application? Ultimately giving you the ability to have a more rich initial set of tests. We then can analyze the tests that are being executed and identify gaps in the code and identify tests that could be potentially be reused to kind of drive your coverage metric and try and drive towards the coverage goals. By reusing these tests and by taking that initial baseline, what we've done is we've guided the developer through the process of creating a meaningful unit test that can be very quickly reused to drive and increase code coverage so that I can get complete coverage of my application. So one of the things that Diego mentioned earlier when he was talking about unit testing is he was saying, well, it's mostly a myth and it's mostly a reality. The myth is that I can push a button and create 100% unit testing. If I do that, then I'm probably got a set of garbage test cases, quite frankly, that I can't maintain. The reality is that you can get that jump start that's going to give you your baseline, that you can be augmented and guided through the process so that you can achieve that higher level of coverage with meaningful, maintainable test cases. And this brings me to the last point where J-Test helps, and that's with optimization. As you start to build out this large code base, large test suite, what you're going to do is you're going to run into limitations where you really, quite frankly, don't have the time to execute all your tests. This is where we can optimize the test execution process by analyzing the code, analyzing the changes, and just identifying which subset of tests, be them true unit tests or component integration tests in JUnit, be able to take those and identify which ones you need to execute to accelerate your process. And I'll actually talk about that just in a little bit more detail because this is actually an example of a real customer. We had a client where they had a distributed development team in Europe and the US. They were very actually sophisticated when it came to their unit testing practices. So what would happen is they would inject some changes into the code base, but their nightly build would break. And because they were a mature organization, when the nightly code or the build broke, everybody would jump on it. So all of a sudden, different teams would be saying, hey, I see that there's a problem. And they would be immediately on top of how do they fix the problem. It ended up with actually a lot of team inefficiency. So what we did was we actually introduced them to this test impact analysis and how we could optimize the process. As we were doing that, though, they said, okay, so let's say I'm an individual developer, and I've made a couple of changes to the code base. If I want to be proactive now, and I want to validate the code that I've tested before I check into source control, I kind of got two possibilities. My first possibility is I may know a couple of tests that I can run. Often organizations will have a naming convention where you have a test-to-test class association, and that will help you identify some tests. But as we saw in the previous example, the previous diagram, there's a whole bunch of other tests that intersect. So really, to have a true understanding that I haven't damaged anything, I have to go ahead and execute all of the tests against my entire test suite. Trouble is, that is going to take too long. If you've got a small set of true unit tests, you probably, if you're following best practices, can run those in 10, 15 minutes, which to some developers is a long time. As you start growing that suite and you start expanding out into integration and component tests, those tests will take even longer to run, often hours. So what we do with our test impact analysis is we're able to not only identify those individual tests which are associated with an individual class, but we're able to actually identify all of the overlapping tests and then schedule them for execution. either directly within the IDE, giving the developer immediate feedback onto the quality of the code that they're committing into the code base, or as part of the CI process, giving you the ability to accelerate your CI pipeline. This resulted in this particular organization reducing the number of build failures as part of their CI process. Because what they were doing is they were able to identify the problems or the regressions before the code was actually executed into or integrated into the code base, integrated into source control, and integrated into the CI/CD process. Okay, so the point here is that this process gives you the ability to accelerate. Oh, sorry, there we go. Gives you the ability to be able to accelerate your testing initiative. And as we were talking about before, with Diego's research, how we can optimize the process, how we can help guide you as to which tests need to be executed and execute those before committing into the source control system, so you can reduce the number of build failures. So really bringing this all together gives me the ability to have a solid testing foundation. So unit testing at the bottom, SOA tests with API testing in the middle. We also have technology like service virtualization, which can also be used to take that testing practice and shift it left. But frankly, we don't have time to go into that level of detail in today's conversation. So hopefully that was a good overview for the folks on the room, on the call, about how our technologies fit in. Diego, I'll turn it back to you, and we can talk about where should people go next.
Sure. Well, I wish. Thank you, Mark. I wish you could also do some demos on the other use cases, because that was really cool, showing that some of this stuff can be done. I saw a comment around that, that point around a statement that how can a use case be mostly a reality and mostly a myth at the same time. Let me explain. I think Mark actually tried to explain it a bit. The point we're trying to make is, well, first of all, these use cases are really variable in terms of how real they can be and how much of a myth they can be, depending on the goal you set for yourself. And the goal you set for yourself depends on a lot of things. It depends on the type of apps you're testing. It depends on the the tools you are using. It depends on and specifically in that case of API unit testing generation. What I was trying to say is that if you set the goal as being 100% unit test generation, then it's a myth, right? Today, because there are companies that are working on trying to solve that problem with AI, that goal, right? But today it's a myth. If you lower the goal and you go between, as Mark showed, with between 50 and 100%, you have tools like the Parasoft tool that can address that. Right?
Exactly.
So after that clarification, so basically that's the first point, right? Assess which use cases have the highest bang for the buck for you. And you will find that some of those use cases in your context might switch a bit. The point is that, you have to assess that. I would also say you have to kind of, starting now is important for two reasons. One is, as you start using more AI in testing, I think you're also going to have to get ready for testing AI solutions, because your business people are telling us, the data shows us that organizations are starting to use AI for building new solutions for the business. We have to test those solutions for the business. And guess what? You're going to need a lot of AI to do that. It's using AI for testing AI. So starting now is important for those two objectives. One is, what can I improve on what I'm doing today? Two, am I ready for the future? So get developers and technical testers familiar with some of these core concepts, throw them at those that are coding machine learning, the machine learning algorithms, and learn about those technologies out there. Prioritize on the realities and look at both augmenting and look at the objective of automation. It's really, in order to achieve higher levels of automation and autonomous, for example, it's clear that we have to go through augmentation of our testers before we can get to the full dream of full automation, if ever. And experiment with those that are myths. Start experimenting today, as I said, because those are the ones that probably will get you ready, or at least on the right track to the AI systems testing itself. And of course, it's always a technology. I'm not encouraging go out and buy all the tools for doing this, but look for the right technology, but also look for using the right technology at the right time. And Mark, I don't know if you had any other thing.
No, I think that's exactly. I mean, there's a lot of buzz around AI. There's a lot of people clamoring to add the technology into their pipeline. Right. I think your first point are going to give you the biggest bang for your buck. And there are lots of different use cases. We talked about two specific ones where Parasoft can help as well, obviously. But I'm a firm believer in the augmenting the process and helping assist the practitioners accelerate that process and create more meaningful tests.
And I think an important point that is not on the slide, and I think it slipped through the something we should have put on the slide, is data, right? Mm-hmm. You can't do much if you don't have data. So you guys have a lot of data. All your projects are generating data. The tools are generating. You've got data in Jira. You've got data you've got log files. You've got the testing tools that generate data. You've got the test cases. You have to start thinking about how you're going to govern that data, how you're going to automate the process to get that data so that you can crunch and you can apply machine learning on it.
Great. So thank you, everybody, for your time today. We'll take a moment to look through questions. So as we do that, I'm going to leave you with a call to action here. So if you want, one of the questions I did see, which is how do I get the Smart API test generator? If you go to the Parasoft website, parasoft.com/try. That's where you'll be able to fill in a form and actually get access to the technology. So let's go ahead and actually just kind of look through some of these questions here. One question, is it a common practice? Oh, that just disappeared. There we go. Is it a common practice of organizations to primarily use mock test data for unit tests, or do they use actual test data?
Well, I think I'll give a quick take to this. I think this is exactly the issue of confusing sometimes unit testing with functional testing.
Yeah.
Right. Definitely, you need good test data for functional testing, and it's very important that there's a process for that, and there are tools and technology again. And so it is while I wish it was more of a common practice, but it definitely has to become a practice, because there's no point automating that's part of the augmentation, if you want, with the right data. And actually that is one of the use cases. I didn't mention it, but it's one of the use cases, which is, can we also use AI to generate and to select the right test data instead of just giving it all the possible combinations of test data that we have in production? Besides, there's issues with GDPR, because you'll have to anonymize it and censor it and all that stuff. So my answer to that is, I wish it was more of it, but you would need that, and you can also create mock data. But for your testing,
I think this ties to a conversation you and I were having this morning, right? Yes. Before the webinar, which is, what is unit testing? Yes. And at the smallest point in my code base, smallest would obviously be a method or a class, and it's typically something that's written in code, like Java with JUnit, for example. However, really many people, when they talk about unit testing, will actually think about not only testing individual units, but testing components or doing some level of integration testing. This is actually where the test optimization within JTest comes in really, really very useful. So when it comes to the data that drives that, the key is, if you're doing the low-level unit tests, you want to have them truly isolated. So your data is embedded within your test scenarios. You're leveraging mocks. You may be parameterizing the data with an external data source, but you're typically not using production data. When you're getting to higher levels in the testing pyramid and you're trying to focus on business logic and business flow, the actual data becomes a lot more important, that it's closer to reality. Absolutely. And that's also where test data management solutions come in.
extracting data from production. It's also where service virtualization can come in as well. That can actually really be used to help simplify a test data problem. But you know, that was a very loaded question that you gave us there, obviously. I would say that yes, if you're in unit testing, true unit testing, then you're going to mock out all of the data layers and you're going to be just embedding the data in the test.
Right.
As you move further up, whether or not you're using a JUnit framework or a functional test automation tool like SOATest, you know, then the data becomes more real at that point.
There's no other questions, I think.
Okay, I think that is, yeah, I think we addressed, yes, the meeting's going to be available as a recording and the slides will be available as well as part of that. But yeah, I think we had a number of audio issues during the presentation by the looks of some of the comments. So apologize for the technical issues that we were having today. But hopefully you enjoyed this session. And Diego, thank you very much for the time.
Thank you, Mark, and thank you, everyone.
All right.
Thank you very much.
Thanks, everybody. Have a great day.